Hey guys, welcome back to GCSE Maths Trigonometric Problem Solving. This is the problem 3 and let's have a look at that. Here's a rectangular field with diagonals lengths of 15 meters each. The angle between the diagonal and the side of the field is 35 degrees. Find the dimension of the field. Alright, pause the video, try to do by your own, that's always the case, and then compare it with my explanations. And we go straight away to the explanations. So this is a rectangular field with diagonals that I set up here. So we are said that the angle between the diagonal and the side of the field is 35 degrees. So let's mark up this angle. It's right there. It's 35 degrees. You need to find dimension of the field. Let's say that this dimension is x meters and this is y meters. Okay, we have two sides and I mark them as, let's say, green one that we need to define. Okay, so we also have a diagonal. I mark with a blue one, it's right there. So we have a right angle triangle. Where is the right angle? It's right there. So here is the right angle. And we have triangle ABC with B as the right angle. So we can consider triangle A, B, and C, from where we can find out X and Y, both of them. So that's 50 meters, stays for AC. So we can say that AC is 50 meters and this is height. So for relating to that angle, X is adjacent side and Y is the opposite side. So we use ratios, trigonometric ratios for the right angle triangle. And we can say that because X is adjacent side, we know for adjacent side we need to use cos rule by multiplying by height. So height times cos of the angle 35 degrees. Okay, if we convert into values, we'll have x in meters is going to be 15 times cos 35. It's pretty easy. All right, from where we can figure out x, go to calculators, take it up and calculate cos of 35. So we've got 12.29 meters. All right, so that was stays for x. And for opposite side, we also can set up similar ratio, trig ratio. It's height by sine of 35, okay? So from where we can figure out that in this case, y is simply 15 times sine 35. Okay, what's the trick here? You start from, let's say, adjacent side, you know this formula, and in order to get the opposite side, you simply swap cos into sine. So the structure stays the same. You also have height, but times, in this case, by sine of 35. So that's how you can get y as the opposite side. So y is going to be, now let's change, simply 15 times by sine of 35, and that's going to be 8.6, okay, 60 to 2 decimal place. Okay, in both cases we have 2 decimal place, and that's the answer for the question. Alternatively, you can use Pythagoras. For example, you figure out one side x, it's 12.29. In order to find y, you can also set up Pythagoras in the way hypotenuse squared is equal to x squared plus y squared. Because you found x at the first step, so you can plug 12.29 instead of x and figure out that y from there is simply a square root of, and you transfer 15 squared stays here and you transfer x squared to the left side, so you'll get basically 15 squared minus x squared. Instead of x squared, you put in 12.29 squared and square it out, and take the next 15 squared, which is 225. You subtract that result in order to get y. So that's an alternative way. But hopefully you know all trig ratios and you can do it in a very fast manner. So that's work faster, definitely, as you can see. So trig ratios works faster. Now you may compare your solutions and the way you did. Hopefully you did it. That was Daniel Dallas. Thank you guys. And we'll move to the problem 4.